Homework sheet 12, question 9. In part A, I'm asked to draw on the same axes two curves. Y equals x squared lots of x minus 2, and y equals x lots of 6 minus x. Our first one, y equals x squared lots of x minus 2, gives me a cubic graph. The x squared is a repeated root, which indicates that the point x equals 0 is not going to cross the axis, but merely touch the axis, either coming up to form a local maximum, or down to form a local minimum. I also have a root at the point x equals 2. This one will cross because it is just a single root. If I just look at the x cubed part of the equation, x squared times x is positive x cubed, which means my graph starts in the bottom left quadrant and finishes in the top right quadrant. So, it's going to start off at negative infinity, come around to form a local maximum, form a local minimum between the points x equals 0 and x equals 2, before cutting back through and tending up steeply towards infinity. My second curve, x lots of 6 minus x, also has a root at x equals 0, and it has a root at x equals 6. Quadratic graph is not going to be as steep as a cubic graph, sorry. So my point is going to come down and it is going to cut through the previous curve. It's going to cut through up here before cutting through the axis and then tending off below infinity. I need to label my points 6, 0, 2, 0, and 0, 0. In part B, I'm asked to find the solutions to where these curves intersect. You can see from the graph that I'm going to have three solutions: a negative solution of x, 0, and a positive solution of x. I'm going to find these by setting my equations equal to each other. X squared lots of x minus 2 is equal to x lots of 6 minus x. If I expand the brackets, x cubed minus 2x squared is equal to 6x minus x squared. And if I get everything to one side, x cubed minus x squared minus 6x equals 0. I haven't just divided by x here because there's a tendency to lose a solution if I do it that way. I'll lose the x equals 0 solution that I know needs to exist up here. Instead, I'm going to take it out as a factor to get x lots of x squared minus x minus 6 equals 0, and then factorize my quadratic to get x minus 3, x plus 2. This gives me three solutions: x equals minus 2, x equals 0, and x equals 3. But I haven't just been asked to find the x coordinates, I've been asked to find the coordinates altogether, which means I need to find the y coordinates as well. I can plug these three values into either of my equations. I'm going to plug them into the one on the left. Minus 2 squared is 4, minus 2 take away 2 is negative 4, 4 times negative 4 is negative 16. At x equals 0, 0 squared times negative 2 is 0. And at x equals 3, I have 3 squared times 3 take away 2, which is 9 times 1, which is 9. Anytime I do simultaneous equations, I should check that the solutions work in the second equation as well. Is negative 2 times positive 8 equal to negative 16? Yep. Is 0 times 6 equal to 0? Yep. And is 3 times 6 take away 3, 3 times 3 equal to 9? It is. Therefore, these are my final solutions.